Reflections.
Okay. And I would say reflections, the translation should be the easier part. Reflections take a little bit of work. Vertical stretch and compression a little bit easier. Horizontal we haven't really worked with. So, okay, lesson 1.6 is graphical transformations. You see at the top of the page there is a chart. This chart is, well, not identical to last year, very similar. Okay, has all the same information on it, set up differently. Yeah, you could always fill an Algebra 2 paper to look at if you want a separate paper. But horizontal translations. That's when we're talking about moving left and right. Notice when we're moving left and right, that number that's added in is going to be in the parentheses, in the square root, in the absolute value. It's going to be in with the x, right? And it's opposite. So if it says minus a value, that means we're going to go right. If it says left, or if it says plus a value, we're going to go left. So this is the one where you listened to me all last year say, it's in the parentheses. We're going to go left or right, opposite the sign. Okay? Then we have vertical translations. Vertical translations mean we're talking about moving up and down, right? And if it's a plus C out, it's not in the parentheses or under the square root or anything like that. It's at the end. We're going up or down the direction of the sign. So if it's plus a value, you're moving up. If it's minus a value, you're moving down. Okay? Reflections. We'll work with reflections a little bit more than last year. Okay? If the negative is out front of the equation, then that negative is going to be a reflection across the x-axis. The x-axis being the horizontal axis, so that means my graph is going to flip upside down. Okay? If my negative is instead just in with the x, okay, so written similar to this, but in with the x, then instead it reflects across the y-axis. The y-axis being the vertical axis, right? So it's reflecting left and right. New this year. We didn't talk about this one last year. If you have both negatives, okay, so that's saying if you're reflecting across the x-axis and across the y-axis, then it's a reflection through the origin. Remember in lesson 1-2 when we talked about even versus odd functions? Even was symmetric across the y-axis, right? Odd was symmetric through the origin. One of my ways I described reflection through the origin was to reflect across the x and across the y-axis, right? I said a double reflection. I also compared it to a rotation of, 180? But it's a double reflection is what through the origin is. You're reflecting across both axes. Now, stretches and compressions is what they were in Algebra 2, yes? This book throws in the word shrinks instead of compression some, okay? I don't care if you tell me it's a horizontal or vertical shrink or compression. In my brain, shrink, compression, same thing, okay? What I need you to realize, though, is when you see that they are equivalent, okay? Now, we didn't really work with this one last year. We are going to work with it a little bit today. But if your value, well, okay, let me start with, this is the one we worked with last year, yes? Where if you have a value multiplying by the function. So last year was a f of x. This day just use c for everything. That is a vertical, when that number is multiplied out front, it is a vertical stretch or compression. Again, this book focuses more on shrink. Vertical stretch if the value is a number bigger than 1. Vertical shrink or compression if the number is between 0 and 1. So basically if it's a fraction or a decimal. Okay? Now, new this year is the horizontal. And with a horizontal stretch or shrink, instead of the number being multiplied out front, it's in with the x and it's dividing. So it's x, if you have x divided by a value, it's going to be horizontal stretch or horizontal shrink or compression. With those values, the numbers are still the same. It's a stretch if the number is greater than 1. It's a compression or shrink if the number is between 0 and 1. Okay? So, now, key. Transformations can be performed in succession, so one after another. If the transformation involves stretches, shrinks, or reflections, the order in which the transformations are performed may make a difference. So we'll talk a little bit more than we did last year about the order. Okay? If I'm just moving stuff left and right and up and down, it doesn't matter what order I move stuff left and right, up and down. It's all going to end up the same. But if I'm moving something, say, left or right, and then also reflecting across the y-axis, it makes a difference. So we'll talk about some of those pieces here. Okay, let's get some easy stuff going here. Example 1, describe how the graph of y equals absolute value of x can be transformed to the graph of the given equation. And A is y equals absolute value of x minus 4. What's happening to that graph? Okay. The minus 4 is outside the absolute value. And so it's up or down direction of the sign. So he said going down 4. What's a good vocabulary word here? Shift. I'm going to use translate. Down 4 units. If you say shift down 4 units or shifting down 4 units, that's fine too. Okay? I went with translated because that's what they officially are. All I ask is that you don't just say down 4. Give me a verb. Okay? What about B? Okay. The plus 2 is in the absolute value. So when it's in with the x, it's left or right, opposite the sign. So this one we are going to say that it is translated left 2 units. Okay, easy peasy. We wish they were all like that. Okay, next. Okay. Example 2. Finding equations. So being able to take what they tell us and write the equation. So we're going to take the description and write the equation. Opposite of what we did up above. Write the equation for each of the following translations. Shift the graph of y equals x cubed down 3 units.
So y equals x cubed.
Okay. So they're telling us y equals x cubed. That's my base graph. They're telling me what to use. How do I show down 3? Up and down is just up or down direction of the sign. Yes? So we're going to go minus 3. Easy enough? That one is, right? Okay, B. Shift the graph of y equals x cubed left 2 units.
Y equals x cubed plus 2 in parentheses.
As in?
X cubed and plus 2 in parentheses.
Like that?
Yeah.
No.
Oh, just kidding. Yeah.
Absolute value.
No?
The cube should be on the outside.
Okay. They mean different things. Okay? This one, I can drop the parentheses, and it still says the same thing. It still says y equals x cubed plus 2, which means this is just an up 2. Okay? This one over here, if I drop the parentheses, well, I can't really drop the parentheses without having to do something about it. Okay? So the plus 2, to indicate left 2, needs to be in the parentheses with the x, but whatever the function is outside of that. So in this case, it was a power. but whether it be absolute value or power or whatever. And we are only going to throw in absolute value when it's an absolute value function. Okay? Shift the graph of y equals x minus 1 quantity cubed, right 3 units. What?
Just x minus 3. Would it be minus 4?
If we just trade the 3 and 1 out, we're not keeping the same original graph.
Absolutely.
Okay? Because the idea is, up here the original graph was x cubed. Here my original graph is already scooted where? It's already scooted right 1. So if we're going to scoot it right 3, then all in all it's going to end up going right 4. So my beginner step would be, okay, y equals, with the x, I'm going to go right 3. So I'm going to say x minus 3. There's already a 1 there, and it's still cubed. So that right there is me putting the minus 3 in with the x. Okay, the parentheses were already there from the other one. When I clean this up, x minus 3 minus 1 is x minus 4. So making you think a little differently there. Okay? Okay. So that's a little bit about translations. Let's look at some reflections. Example 3 asks us to find equations for reflections. And it just says find an equation for the reflection of, and we're actually going to find 3 different equations. Because we have how many different reflections we could do? 3. So we're going to start by looking for an equation to reflect across the x-axis. What's my chart say about reflecting across the x-axis? Okay, so we're going to have negative f of x. Negative f of x means you take the equation and multiply by a negative. Now, I'm going to start us off with the negative of, and I'm going to put in parentheses, 5x minus 9 over x squared plus 3. And this is a little bit different because it's a fraction, isn't it? If this was just the terms, you would just multiply each term by a negative. Because it's a fraction, what are options? How do I multiply a fraction by a negative? Okay, we only do either the top or the bottom. Because if you multiply top and bottom by a negative, what's a negative over a negative? A positive. So you can't multiply top and bottom by negative, or we're really not doing anything. Okay? Either pick to apply that negative to the top or to the bottom. What I will say with this, the other option, and I'm not a huge fan of this because you have to be very particular, is to just put the negative sign out front of the fraction bar. So if we put the negative in front of the fraction bar, then we're applying it to neither top or bottom. But if you don't write it exactly right, where does that negative end up? It ends up like with just the 5x or just the x squared, which is why I hesitate there. Okay? So my suggestion, usually where we're going to probably take it, probably to the top. And so just take the negative and essentially distribute it to the top. If we do that, negative f of x is going to be equal to, what happens when I multiply the top by a negative? Negative 5x plus 9 all over x squared plus 3. Okay. Okay, that was reflection across the x-axis. Let's try another one. Let's try a reflection across the y-axis. Okay, what's a reflection across the y-axis going to do? Okay, so if you go back up to your chart, across the y-axis says to do f of negative x. Okay, f of negative x. Every place we see an x, replace it with negative x. So every x is going to become a negative x. So 5x, I'm going to write it right now as 5 times negative x. Minus 9 is still minus 9. X to the second, I'm going to write it right now as negative x to the second. Plus 3 is still plus 3 because there's no variable. Okay? So we're applying a negative to every x. Now, clean it up. What is 5 times negative x? Negative 5x. Still with a minus 9. In the denominator, what is negative x raised to the power of 2? Negative x times negative x is going to become positive x squared, isn't it? And then the plus 3 stays plus 3. So I have this as negative 5x minus 9 over x squared plus 3. So reflection across the y-axis. Every regular x term changes signs. It's like 5x changed to negative 5x. Squares aren't going to be affected. Okay, and one more. Across the origin. Across the origin says we're going to be doing both of these, right? So basically we're going to take both things we just did, combine it into one. So this is going to be negative f of negative x. So one thing, it's going to be the negative of the whole function. So the whole function is going to get multiplied by a negative. And then also at the same time, every place I see an x, I'm replacing it with negative. So 5 times negative x minus 9 over negative x to the power of 2 plus 3.
Could you technically just take the f of negative x and
Like take the one we just did here across the y and then
one of the
yeah. Okay. Now I'm showing it all, doing both. But yes, could we have just taken our across the y-axis answer and multiplied by a negative? Yes, because essentially that's what I'm going to do. Because I'm going to tell you to start in the parentheses. So I'm going to say leave that negative out front for right now. And I'm going to say clean up inside the fraction first. So if I do that, it's negative 5x minus 9 over x squared plus 3. What do I need to do with that negative out front? Distribute it to either numerator or denominator, yes? So negative f of negative x becomes positive 5x plus 9 over x squared plus 3 still. Okay. Okay. The next page talks about, we move on from reflections to stretches and shrinks, or stretches and compressions. And notice, this is where we're going to have to be a little bit different from what we did back in Algebra 2, but the directions ask us to state the horizontal or vertical stretch or shrink. Okay? And they're telling us f of x equals x squared to tell you, okay, what is our base parent graph? Okay? Our base graph is x squared. Now, some of these, we're actually going to have two different answers. What do you know about A, though?
Horizontal. Vertical, just
Okay. That 2 is just out front, like right here, yes? The 2 is just out front of the function, and so that is going to take it into the vertical category. So yeah, that first one is an easy one. It's going to be a vertical stretch by a factor of 2. Okay. When we talk about B, notice there's a difference, isn't there? Okay, you've got those parentheses. You've got value in with the parentheses. There's going to be two different ways we can talk about that tomorrow. And so we'll talk about how we can make that look like a horizontal stretch or shrink, and we'll also talk about how we can make it look like a vertical stretch or shrink. Okay, so we'll talk about that tomorrow because that problem's going to take a little bit more to fully understand. Homework, you can start.